starting off here, my party people, adding and subtracting fractions. Let's go ahead and fill in the blank here. To add or subtract fractions, the fractions need to have the same what? Fractions need to have the same what? Denominator. That's right. Denominator. If you were here yesterday, I kept saying denomination for some reason. Well, I mean, I was sick, but yeah, they need to have the same denominator. Right there. So can we add or subtract these following fractions? Everybody, I'm going to give you guys 30 seconds. And what we're going to do is I'm going to give you 30 seconds to give me 3 yeses or nos. So give me yes, no, or yes, no for the first 3, 1, 2, 3. So I'm going to give you 30 seconds. Nobody typed the answer in yet. I'm just going to give you 30 seconds starting now. And at the timer, then you'll go ahead and give your answers. So there we go. I mean, y'all could have waited until the timer was up, but I told you to wait till the timer was up. Now I'm thinking to myself, like, maybe I misspoke. All right, 3, 2, go ahead and repeat your answers if you already put your answers in. Go ahead. It's all good. I'm going to cut you guys a lot of slack today, man. I am going straight to bed after this, man. I'm still not feeling right, but it's all good. So I don't know how to add or subtract fractions. It's all good, Ryan. I got you. We're going to have a brief review here, but remember that today's class is about the word problems. So I want you to just, as frustrating as it might be, to not be able to add or subtract confidently right now. We did that in the previous class, 2 classes ago, and I'm going to give you the recording for that. I'm going to show you how to get there. But what I want you to focus on today is really spotting those keywords and basically turning the English into math. So you don't have to worry about too much about calculating. I'm going to take care of that for us today. So this is me speaking to everybody. I am not expecting y'all to be adding, subtracting, multiplying, dividing like pros right now. I'm not expecting that. So I'm going to take care of a lot of the calculations today. Our focus is going to be on the keywords and turning that into a plan that we know will work. All right. So that's what I want y'all to focus on. So the answers here were the following: yes, no, no. That's what it was right here. Yes, no, and no. So my party people, remember this and fill in the blank. To add or subtract fractions, we need to have the same what? Need to have the same denominator. Jalen, Jessica, congrats on being lazy. So with that denominator, they have to have the same denominator. So with that, the thing is, well, what if you don't know what the denominator is? Everybody, is the denominator on the top or the bottom? It's on the bottom, right there. Exactly. It's on the bottom. So right here, these are the denominators. Those are the denominators. All right. So we're not going to add these right now. I'm just kind of refreshing on that. Because what we're going to do next is we're going to find the least common denominator of these 4 pairs of fractions. And we're going to use that to, again, just keep warming up. We're going to be talking about the majority word problems in about 15 minutes here. So here we go. Find the least common denominator of these 4 fractions. Can anybody go ahead and describe to me what a least common denominator is? Because we're going to go ahead and write that down as a refresher. What is a least common denominator? And you can raise your hand if you'd like to explain it. What's going on, Israel? Go ahead. And I'm reading here in the chat box. We have a number that they have in common. Okay, Israel, want to expand on that?
The least common denominator is the least common multiple of the 2 denominators.
Exactly. LCD, or least common denominator, is simply put the least common multiple of those denominators. And what we mean by least common multiple is basically multiples or numbers that these share in common. So let's go ahead and write that down, everybody. So right over here, let me go ahead, read that background noise. So with that least common denominator, what it's going to be is this. The number, I'm going to simplify this. I'm not going to give you like the that formal textbook math. I'm going to try to write this in as English as possible. So the number that both denominators can multiply into. And remember, denominator just means the bottom. So that should be the most complicated word there. That really should be it there, the word denominator. But again, denominator just means bottom. So I want you guys to go and write that down. Least common denominator, the number that both denominators can multiply into. And so we want to say the smallest one, because that's what makes it least. So smallest right there. So let's add that in. And now let's take a look at some of these examples just to refresh ourselves here. So boom, over here. What's up, Mo? So let's go ahead and take a look at 1/4 and 9/8.
Hey, quick pause here before we continue this session recording, which I'm really proud of you for sticking to and getting the information that you need. I want to tell you about my ASVAB All-Access Program. This program is everything that my students need to raise their scores and get the jobs they want, because it has all of my classes, every single one that I've ever done, organized for them, so you don't have to worry about coming to the live ones. You can actually watch whenever you need to. And on top of that, you can text me whenever you need help and get access to thousands of extra practice problems for the math, the English sections, general science, plus practice tests and study guides. So I'm making this program here everything that you'll ever need to pass the test, and I update it periodically for free at no extra cost. So go ahead, check the link out in the description of this video, or shoot me a text, 567-698-8867. I'm Coach Anderson, and ask me about my ASVAB All-Access Program. That way you can raise your score, stress less, blank out less test anxiety, and get that job you deserve. So let's get back to the session recording, but let's make sure to do that and ace the ASVAB.
So everybody, the denominators are what two numbers here? The 1, the 9, the 4, the 8. What two numbers are the denominators here? Correct, the 4 and the 8. So what we'll do is we'll ask ourselves, okay, what number can both 8 and 4 both multiply into? What's the smallest number that they can multiply into? So y'all are saying 2, but I think you guys are getting confused with factors. Remember, everybody, multiples are this. 4, its multiples are going to be the following numbers. Are going to be 4, because 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12, 16, 18, 20, wow, 20, 24, 28, etc. Now, if you look at the number 8, let's go ahead and list those multiples. Everybody, 8 times 1 is 8, 16, then 24, then 32. Then we're going to have ourselves 40. And then we just keep going, ... So with that said, everybody, we have a couple of numbers that we could use. We have a lot of the same denominators. We have a lot of common multiples here, and I'm going to point them out. We've got over here 24. Heck, we've got 16. So we use a different color for that. We've got 16. And heck, we also have 8. So the thing is, we always want to use the smallest one. By using the smallest one, you guarantee that you're not dealing with bigger numbers, which means that you have to simplify less. So that's a good thing always. It's always a good thing to use the smallest version. So here we go. We are going to use 8. All right, before I continue, yes or no, does it make sense when I say least common denominator, you grab the denominators, list the multiples, the one that they both go into, that's what you want. Did that part make sense? Oh, no, you're good. Yeah, because I understood that y'all were thinking factors when I said multiples, so I just wanted to make sure I cleared up that difference before moving on. Yeah, I gotcha. So here we go. The common denominator is 8. Question, yes or no? Do we need to do anything to this fraction? Do we need to do anything to that 9/8 over there? Oh, nothing. We don't need to do anything. We don't need to do anything. Because the thing is, the least common denominator is 8. We're already at 8. Over here, what do we have to do to this fraction, to the top and the bottom, though? What do we have to do to this one to make it 8 on the bottom? We got to multiply by 2 on the top and the bottom. Can anybody explain to me why we are multiplying by 2 on the top and the bottom? What the heck is with that? Who can explain that to me? I don't want to confuse anybody. Can anybody explain to me why? Jalen, go ahead.
Because the denominator will turn into 8 if you do it on both sides. Or the bottom and top, my bad, bottom and top.
Oh, you know, you're good. Yeah, I see exactly what you mean there, Jalen. So Jalen says, and stay on the mic there. Oh, let me go ahead and give you the mic again. So Jalen says we should multiply the denominator by 2 to make it 8, which is perfectly right. But why is there a 2 also in the numerator, Jalen?
Because you have to do it on like the bottom and top.
Right, but why is that? Do you know why though?
Whatever you do to the top, you have to do to the bottom, right? Like, or am I wrong?
Right. So you gave me the command. You gave me the rule. But what's the reason for that rule?
Yeah, I even know.
It's all good. It's all good, Jalen. So this is a teaching moment. So this is basically you getting free one-on-one tutoring. So here's what's going on, Jalen. The thing is, we don't just want to memorize these rules. We want to completely understand them, because when we do, this is where that confidence can really soar. And then that timing really goes down. You do it super quick. So Jalen over here, one-on-one with me, man. Everybody, or Jalen, what's 2 divided by 2?
1.
Right. We know that. Dumb question to ask. So the thing is, we're really multiplying this whole fraction by 1. Yes. We're not really changing the actual value. Because remember, when you multiply by 1, the number doesn't change, right?
Yeah, it doesn't change.
Exactly. So what we're doing here is we're just changing the way the fraction looks so we can talk about both fractions at the same time. It's the same as imagining having 2 boxes of pizza. If we have 2 boxes of pizza here, let me duplicate this right there. Think of it like this. If I have box A and I cut that into 4s right here, because again, the denominator is 4, you're dividing by 4, so 4 pieces. And if you take a look at box B with 8, think of it like this, Jalen. Can we bring slices from this pie to this pie?
Yes. Yeah, you can.
Can you do that without noticing that they're from a different box?
No.
Not quite, right?
Yeah.
If I eat one of these slices and I try to replace it with one of mine, it won't fit, right?
Yeah, exactly.
Exactly. Yeah. You see how much bigger it is. So we can't freely talk about exchanging, oh yeah, give me one slice of this pie and one slice of that pie. They're 2 completely different sizes. They're not cut in the same way. Okay. So here's the thing. By multiplying by 2 on the top and the bottom, let me go ahead and do this for you right here. 1 out of 4, let me just highlight that right here. Here is 1 out of 4. Okay. That right there, 1 out of 4. So after we go ahead and multiply the top and the bottom by 2, help me out, Jalen. What's 2 times 1 going to be?
2.
And then over here, 2 times 4 is going to give me
8.
Sounds good. So now this is saying 2 out of 8 slices. But what I'm willing to tell you right now, Jalen, is that, 1 out of 4 slices is the exact same as 2 out of 8. They're the exact same. Let me prove it to you. I'm going to add these extra cuts right there and right there. Do you see that I didn't change the shading?
Yes.
It's still the same piece of the pie, but I just made it so that now if I wanted to take a slice from here and put it over here, I can absolutely do that freely, knowing it'll fit.
Cool. Cool. Okay, that makes a lot of sense. Yeah, that makes a lot of sense. Appreciate it.
Yeah, no worries, man. So again, everybody, the idea here behind the least common denominator when you're adding and subtracting is simply because you need to be talking about the same pieces of the same whole. That's it. That's it. So that's why we do that. So let me know everybody else in the chat box. Does that make sense? All right, cool. So again, we need to be talking about the same pieces of the same whole. So right there, 1/4 would translate to 2/8. Let's go ahead and go over here. Everybody, what do we notice about these denominators, 10 and 2? What do we notice about those? What do we notice about those? Yeah, both can go into 10. Just like in the last problem, both of these can go into 10. Everybody, I can make these denominators the same if I take the 2. Everybody, 2 times what is 10? 2 times 5 is 10. So if I went ahead and just said, yo, I'm going to magically multiply the bottom by 5, that's illegal. What do I also have to do? Right, 5 over 5, multiply by 5 on the top and bottom. Got to do it on both. For the simple reason being, again, this 5 over 5, it's the same thing as saying 1. You're multiplying by 1, which doesn't change the value. It'll just help us see the fractions in the same way. So we can add them. So here we go. 9 multiplied by 5 is going to give me 45. And 2 multiplied by 5 is 10. So then 1 over 10 and 45 over 10, now they have the same denominator. So if we wanted to add them, subtract them, we absolutely could, knowing that we're all set. Next up, we got 6 and 4. Everybody, let's go ahead and find out what we need here. And so before I begin, everybody, does 4 go into 6? Does 4 go into 6? No, the answer there is no. Because you think about it, 4 times 1 is 4. 4 times 2 is 8. 4 then 8, it skips 6. So this is one of those situations where you actually have to think about what the multiples are. So here, 6 and 4, let's go. Let me list out the multiples of 4. Okay, we have 4. Again, 6 can go into 4. Then we have 8. Can 6 go into 8? 12. Can 6 go into 12? Yeah, again, 6 can go into 12. And so that's going to be the answer. And so if you want to list it out, you absolutely could, because you'll see you have 6, then 12, then 18, 24, ... But we see it right there. Way too big there, excuse me. Boom and boom. So there is your LCD. So you want to try to get 12 as the denominator now. Yes or no? Is that making sense? Once you have the LCD, in this case 12, we want to make this fraction out of 12 and that fraction out of 12 so that, again, they can speak the same language. So with that, everybody, let's ask ourselves, how do we go from 6 to 12? Times 2. That's correct. So I'll go ahead and multiply by 2 on the numerator and the denominator. And so once we do that, everybody, 8 times 2 is what? Sounds good. 16. That's correct. And then 2 multiplied by 6, that's going to give us 12. Okay. Okay. Let's try to get the same denominators over here. So we're going to have 7 over 4. We'll multiply the top and the bottom by what, everybody? Multiply the top and the bottom by what? All right, by 3. So once we do that there and there, we're going to have 21, because that's 7 times 3. And then we have 4 times 3 is 12. And we're good there. So boom, there we have the same denominators. And now we're set to move forward. I think someone might have asked earlier, can we just turn the 8 over 6 into 6 over, what was that going to be? If you divide both of them by, no, because you're taking away the 2. So that really wouldn't make sense, actually. So yeah, Alex, well, that's exactly what we did. We just took a little bit of a longer route. Yeah. And so let's go ahead and warm up real quick from yesterday's class, multiplying fractions. So really quick, just to remind you on the rules, you want to multiply the numerators, multiply the denominators, and then reduce the fraction or simplify if necessary. Okay. Simplify if necessary. So everybody, what was the main takeaway when it came to multiplying fractions in yesterday's class? What was the main takeaway? Mama says simplify. What do you mean by simplify? Give me a complete thought then. Simplify, then multiply, right? Yeah, simplify first. Simplify first. That's what we want to think about here, because here's what happens. When you simplify first, you give yourself easier numbers to deal with. So I'm going to just go through the first one completely, and then I'm going to give you the walkthrough for 2 and 3, or I'll let you guys try out 2 and 3. And then we're looking at the dividing fractions, and then we're getting into our word problems. Okay, so let's go ahead and wrap up here. if we were to go ahead and do this straightforward, what we would get is 2 times 15, which is going to be 30. 3 times 14, that's going to be 42. Again, this is the rule for multiplying fractions. When you multiply fractions, multiply the tops, multiply the bottoms, go about your day. So now step 2 is going to be, yo, we need to reduce these. We need to go ahead and reduce these. So let me go ahead and grab this, duplicate it over here, and show you how to get it done. Here we have to ask ourselves, what do you mean by reduce? Well, you have to ask yourself what number goes into both the numerator and the denominator. So can anybody tell me what number goes into both 30 and 42? What's the biggest number that can go into both 30 and 42? What's the biggest one? 6. I agree. I agree that 6 is the biggest number that can go into both 30 and 42. So let me go ahead and show you what that looks like here. So everyone, what is 30 divided by 6? Like, what happens if you take the 6 out? What do you have? Right, you're going to have the 5. So let me write 6 times 5. Now, what about the 42, everybody? If I went ahead and took the 6 out of the 42, what's left? If I divided that out, you got 7. Exactly. So you have 6 times 7. So now that you have this and you're checking this out, everybody, again, just like yesterday, I'm going to refresh you on this. Doesn't that line right there, doesn't that mean division with a fraction? Doesn't that mean division? It does. It does. And what happens when you divide the same number by itself? They cancel. And that's what simplifying is. When you simplify fractions, what you're doing is you are canceling out what you can cancel out to give yourself the smallest fraction possible, the smallest version of it. So you're not dealing with ridiculously big numbers. We want to simplify the conversation. So the answer is 5/7. Boom. So in this case, this is pretty straightforward. But the reason that I recommend that you, again, simplify first was because of this. Here you can see that 3 and 12 are both divisible by 3. So again, we have 3 times 1, the 3 is gone. This is 3 times 4, the 4 is gone. Now, looking forward, we're good. Now we can go ahead and just go 1 times 11, which is 11, 5 times 4, and that's 20. And you can be done. So that's an easier way to go about it than to go ahead and multiply straight across. 3 times 11, 33. 5 times 12, that'll be 60. And then you have to figure out how to go ahead and reduce bigger numbers like 33 and 60. So in that case, yeah, you can divide by 3. And that's the same 3 that you had right here and right there. The same 3 is right there. All right. So I'm going to let you guys try this last one out. I tried the second one out accidentally, but I just wanted to keep rolling with the flow. So I'm going to give you here a minute to try this one out. See if you can reduce it if you can first, or do the method you're comfortable with, multiply across, and then we will reduce. So here is the timer. We're going to stop it at the 30-second mark. We're going to stop it at the 30-second mark. So what we could do is just straight across multiply 18 over 15. And then what you could do, you can see that 18 and 15 are both divisible by 3. Again, this is the simplifying part of what we're doing. Here we are simplifying. We can divide both the top and the bottom by 3, which will give us a final answer of 6/5. Boom. So with that said, hey, what's up, Romeo? You can actually do that through the website. I'll go ahead and type the link in for you in a moment. I got you. So there is that 6/5 right there. Now, I'm not going to go through the shortcut here because we're going to go into dividing fractions. I'm going to go briefly into, again, the strategy behind this. Keep, change, flip. Again, we did just go over this yesterday. So if you're having trouble with this today, as a reminder, we're not focusing on the calculations today. we're focusing more so on the word problems. So I'm going to go over this one brief question here at the top, and then we are going to move forward. So let me go ahead and just rewrite that question here, 3/2. All right. So when you're dividing fractions, you're going to keep, change, and flip. What that means is over here, I will keep this fraction the same. I will change the operation from division to multiplication. And then we'll flip the second fraction. All right. So what I'm going to do is I'm going to basically duplicate that, put that right over here. And I'm going to show you in real time what I'm talking about. So this is exactly what I'm talking about, everybody. We're going to keep the first fraction the same. Right over there, keep the first fraction the same. Then we're going to change the operation from division to multiplication. So that's gone, and that will be replaced with multiplication. And then we're going to flip the second fraction. So we have 8/5. This is now going to be 5/8. Boom. Yes or no, everybody? Are we good on that? Just the 3 steps. Keep, change, flip. Keep it the same. Change the operation. Flip the fraction. Cool. And then after that, well, now you're just multiplying fractions. So you just go straight across and you're set. You just go straight across and you're set. So there you go. Multiply across. 3 times 5, that's going to give you 15. And then 2 times 8, that's going to give you 16. And you're good. And you're good. So again, today's focus is not calculating. It is not calculating. I promise you that. Today's focus is going to be about the word problems and keywords. So let's refresh real quick on some keywords before we continue. And again, if you are having any issues with the calculating part, just please first take a look at the recording from yesterday and the previous fractions class, and then come back to me with this because there's a lot to learn in there. There's a lot of confidence to build. And then tomorrow we are releasing all of that practice for you. So let's talk about keywords here. I'm going to go through these nice and slow so you can take them down and take screenshots. So whenever you're looking at addition or looking for addition, really these keywords will very likely point you in the right direction. And the reason that I say very likely is because it's not always guaranteed. So I want you to take a look at addition to see really what I mean. And well, actually, I'm just going to ask y'all because I'm pretty sure y'all are going to say yes anyway, but y'all tell me. Everybody, yes or no, and be honest, please be honest. Have you ever done a word problem, where the question asks you for a total, but you actually didn't add in the problem? Have you ever done a word problem that's asked you to find a total, but you actually never added anything to begin with at all in the problem? You didn't need to, right? Okay, you're all saying yes. So here's the thing. A problem like this, here's an example. What is the total distance that the car traveled? And I give you a rate and I give you a time. You're not adding in that problem at all. You're multiplying because it's a distance, rate, time problem. What's another question? Okay, well, you're talking about shapes, and the problem could ask you, what is the total area of triangle S? What is the total area of triangle S? You're not adding anything. In fact, you're multiplying. Okay, sounds good. Here's another example. What is the total interest earned over 5 years? That's interest. You're not exactly adding all the time there. So everybody, did I make my point? The word total does not always mean add. It's very likely that it'll tell you to add, but it's not a guarantee. So what can you do about it, right? I think the biggest question here is, what can we do about it? What you can do about it is pay attention to the problem. The context gives it away. Like, I want to really make sure that you understand that this is not something that's impossible. Like, if I can do it, you can do it too. You know, it's not something that is impossible, you have to guess at. There are factors and things you want to look out for. And context is so important. Again, the story of the problem. Because if you see that you're given a rate and you see that you're given a time, if they ask total distance, That's DRT. But if they say Jimmy has 5 candy bars and Joe has 10 candy bars, how many candy bars do they have in total? Well, context tells you that he has an amount and he has an amount, and a total amount you add. So everybody, yes or no, can we get around the idea there that we shouldn't always get angry when total doesn't mean add, or when, you know, the difference of or less than doesn't exactly amount to everything else? Context really, really matters here. So that's why I always say paint the story, paint the picture. So with that, subtraction, hopefully you had a chance to write these down already. Subtracted from, minus, difference of, less than, decreased by, fewer than, take away. All those mean subtraction or can mean subtraction. Multiplication, multiplied by, clearly, times, product of, twice of. Another one that we could add here is per. Everyone, where's another column that we could include the word per in, or we should include the word per in? Which other column can we also write per? Exactly, division. Division is exactly right. And I wrote the word division. That Dayquil is wearing off. So per right there. There it is. So here's the thing. When you're dealing with the word per, you could be multiplying, you could be dividing. It really depends on if you're trying to work forward in the problem or work backwards. So pay attention to the context. And then equal, we have equal sign, or is, are, was, will be, gives, yields, sold for, equals, all of that. All of that. Oh, the word yields comes up. Whenever you're talking about chemical solutions, have you guys ever done mixture problems where they're talking about, yeah, if you mix, if you mix 20 liters of solution A with 25 liters of solution B, it creates a solution that is 60% solution A. Sometimes they'll replace it with, it yields a solution that is 60% solution A, or whatever. So yeah, those are the problems that'll happen in. Very rare, obviously, you just called it out, but it is in there. It's just like a really deep, dark corner of the ASVAB that you really don't have to worry about too much, but it's a good idea to know what it means. So here we go, we got practice time. Don't worry about this right now, guys. We're gonna go to the first problem together, and then we're gonna start timing. But I'm not timing you to get the problem correct. I'm gonna be timing you to basically get to a certain step of the problem. And what are the steps? Right over here. Everybody write these down. Our 3 steps are this. Number 1, you got to figure out what you want in the problem. Does anybody here get anxious when they start word problems? Does anybody here get anxious? All right. Now, that's fair. Word problems, you kind of don't know what you're dealing with. You don't know what situation you're dealing with. You don't know what you're supposed to be looking for. You just got to tackle it, right? So let's replace that anxiety with strategy, with action, right? So for example, it's like saying, hey, I'm really afraid that a family member might suffer from a heart attack one day. Like, that's scaring me. That's giving me really a lot of anxiety. Well, of course you can't control every aspect of everything, like what the story might be about. But one thing you can control is, hey, at least let me be prepared. Let me learn CPR. Let me buy an AED. Let me go ahead and know where the nearest medical center is. That way, if this does occur, I'm prepared to handle it regardless. That's the best I can do. That's the best. That's the most I can control. Same thing here. What you can control is, well, it's not going to be the story. It's not going to be anything about the context. What you can control is recognizing the keywords, recognizing the question, knowing what you're looking for. So snap your attention, not to the anxiety, but to the question. What do you want? Right over here. That is the question. The first thing you need to do is look at the question, not the story, not Cindy heads west at 45 miles. Nope, you do not care about that. You don't want to worry about that because your mind's going to start making assumptions, and you don't need to make assumptions when you have no clue what you are supposed to do. Going to the question tells you, find this number. We need this part of the story. This is what we want. Literally, word problems is just storytelling with math. That's it. That's all word problems are. So over here, question, what do you want? That's the first thing you do. Number two, what you're going to go next to after that is make a plan. What do you have? Write your information. You can't make a plan without information. So once you understand the question, when it says, oh, how many total watermelons do Jimmy and Joe have altogether? Well, when you read that, you're saying, okay, we're talking about watermelons, Jimmy and Joe's watermelons all together. Okay, the totality, the total of them. Okay. I'm gonna read the question. I'm gonna read the problem now, look at the information. And my only goal is when I read the problem, I want to know about Jimmy, Joe, watermelons, and how many they got, because I need to add them all up. And so you're grabbing all that information. Yes or no, everybody? You picking up what I'm putting down? I know it's an easier example. I know. But I want to make sure you understand the idea that I'm expressing here. Replace your anxiety with strategy. So with that, once you write down the information that you have that relates to getting the question correct, this is where you build your plan. This is where you build your plan. What's the connection? How do you go from what you have to what you want? And you can't just stare at the numbers. I've done a lot of research in terms of observations when people take tests. And one thing that I see people do a lot of is they'll focus on the numbers, but not the story. They're like, okay, I got a fraction of 1/4, and I got 6 over there. Do I multiply them? Do I divide them? Do I add them? Do I subtract them? Okay, look, I'm just gonna go ahead and add them. And if I see the answer there, I'm going to put it there. Does that sound like anybody? Does that sound like you potentially at some point in your life? Again, look, I've been doing this for a while, and I've done a lot of research on this stuff, man. The best way to go is not to focus on what the numbers are, to focus on what the numbers mean. I say this all the time. What does that number mean? Don't just read it as 45. Read it as 45 miles per hour. Oh, miles per hour, that's a rate. Is this a distance rate time problem? Boom. Now you're asking great questions. Not, do I just take that 45 and subtract it somewhere? You see, one's rooted in curiosity and advancing the problem. The other one is just kind of hoping and wishing. So think about what the numbers are stop thinking about what the numbers are and focus more on what they mean. I was reading Armani's comment and I was like, what? I will call y'all out. But it's from experience and it's from love. So I got y'all. So here we go. Let's start this first problem off. Everybody, what's the first thing my eyes need to snap to? What was it again? What's the first thing my eyes need to snap to? The question. So right here, how many feet of yarn did she use in all? That's where your attention snaps to. Let me go ahead and label that with a 1. That's step 1. Read the question. So what are some things that we should underline here? Well, the action here, the question word or phrase, how many feet of yarn? So we want feet of yarn. And then what's another phrase here that we might want to underline? Yeah, in all. So here's the thing, everybody. The question will always give you what you're looking for. It will always give you what you're looking for. And then sometimes the question, it might be necessary for it, or they might just give it to you in the question. They might give you some extra information that'll tell you what you need to do. And in this case, that's going to be the in all right here. Because what that's going to tell you is that you're finding the total amount of yarn used. Find all the yarn used. Yes or no, everybody? Did that make sense? Again, I don't know what this problem is about. I don't know what is going on. I know that maybe there's yarn involved, right? There has to be yarn involved, but I don't have to read the whole story to understand that. I'm looking for how many feet of yarn in all. So how much of it was used in total? Find the total amount that was used. I don't know what I'm about to read. This could actually be a story about Paw Patrol. I don't know, but it doesn't matter. Get the important information here and keep it moving. So let's go. Yvette made a washcloth using 3/4 of a foot of red yarn and 2/6 of a foot of white yarn. Okay, sounds good. Yvette made a washcloth using 3/4 of a foot of red, 2/6 for the white. Okay, so let me go ahead and highlight that right there. Using this much and this much. Okay. Everybody, did they say to care about what color of yarn was used? Okay, so we don't need to include that it's red yarn or white yarn. All I know is that I got 3/4 of a foot and 2/6 of a foot. So what am I supposed to do with both of those numbers? Right, we're supposed to add them up because again, in all means find that total, right? Means find that total. So that's exactly what we're going to do. So bam, 3/4 and 2/6. What I am going to do here is add them. 3/4 plus 2/6. Okay, and everybody, doesn't this look a little familiar? Didn't we have a question earlier where there was a 4 and a 6 in the denominator? What did we find that least common denominator was? What do we see? Yeah, we saw that it was going to be 12. So let's go ahead and rewrite these with denominators of 12. Let's go and rewrite these. Okay, let's go. What do we multiply the 4 by to get to 12? Right, 3/3, and then we'll do 3 times 3, which is 9, 3 times 4, 12. From there, what we have is 2/6. Everybody, we multiply the 6 by what? Yep, 2. We multiply by 2/2 in this case. So 2 times 2 gives us, right, 2 times 2 gives us that 4. We're in business. So what is 9 plus 4, my party people? Gonna be 13. Remember, when you're adding fractions with the same denominator, this is the number of slices that the pizza can hold. So this right here, that's the number of slices that the box can hold. You don't add a denominator. No, you're good. You're still only able to hold 12 slices, but you have 4 plus 9, which is 13 out of those 12 slices. So there we have it. There's our answer. 3/12 of a foot of yarn, or 3/12 feet of yarn. All right. So with my big old head in the way over here, I'm gonna go ahead and move myself back. If we're taking a look here, the question that a lot of people ask really is, do we turn that improper fraction into a mixed number? What do I always say? Exactly. Look at the answers. Look at the answers. If I look at the answers, is it necessary for me to go ahead and turn that into a mixed number? Is that necessary right now? No, not necessary at all. We can go ahead and circle that right there. Boom. There we go. Answer is A. As a mixed number, good question, Ashley. That would be 1 and 1/12 as a mixed number. So a mixed number is like saying, instead of saying 3/2, you could just call that 1.5. Because if you use a calculator, 3/2 is 1.5, and 0.5 is half. So if you do the calculator, you get 1.5, which is the same thing as saying 1.5. So that's all a mixed number is. It's just a different way of representing an improper fraction. Improper meaning when that top is bigger than the bottom, it's technically bigger than 1. And if it's bigger than 1, then we might want to go ahead and just be able to talk about it a little easier. Yeah, it's just the integer and the fraction, the whole number plus the fraction. So with that said, let's go ahead and take a look at this next problem here. And then after that, I'm going to start taking questions about the different parts of what we're doing here. So David, if it was part of the answers, how would you simplify it into a mixed number? We'll go over that on a need to know basis. All right, I got you. Because we did go over that. Did we go over that in the adding and subtracting one? If we did not, then I'll just make a video on it, but we're going to focus on the word problems today. I will make sure that there's a video in the Math Bootcamp for this, for sure. All right, so let's take care of this next one here. What I'm going to do is I'm going to give you all a minute and a half. And in this minute and a half, what I want to do is I want you to go ahead and just do your best in pointing out what the question is asking you to do. If you can do more than that, great. That's great. If you can do more than that, great. But what I am looking for is your ability to take a look at this and be able to point out what you can do with the numbers once you have them. Then step 2, if you can, write the information down. And step 3, if you're able to, solve it. So let's try it out.
I've been teaching for over 10 years, and I got a master's degree in math education, which is my specialty, but I also teach English and general science as well. At the end of the day, I want to make sure that you can stress less and not have to worry about having anxieties about the test, being able to actually not blank out and feel confident about what you're doing. And at the end of the day, are you able to study consistently and know that you are growing? That's really what matters to me the most at the end of the day. So that's why my program is here for you to help you succeed. It has everything you need: the classes, all the recordings, all the practice you'll need, and the ability to text me directly so you have your coach with you, mentoring you every step of the way until you pass. I'm serious about your success. So go ahead and click the link in the description of this video or somewhere over here. That way you can watch how it works, see all the details, and sign up and start raising your score right away. If you have any questions, my phone number is 567-698-8867. Again, I'm Coach Anderson. Text me and ask me about the program, or click the link and watch how it works. Let's get this done. Let's raise your score and get you that job you deserve. Let's get to it.
Step 1, how many miles? Just read the question here. How many miles so far? Sounds good. So that's step 1 again. The number of miles that you've ridden so far. So basically, add up the miles to this point. Okay, step 2 would look like this. What information do we have? What are we talking about? Step 2, we see here that you rode your bike this many miles to the clothing store. Then you rode your bike another that many miles to the grocery store. Okay, so we went to the clothing store and the grocery store, and you rode this many miles there, this many miles for that one. Everybody, do you see how it does not matter? It does not matter what the numbers are. They're fractions right here. Would anybody here get anxious and not even continue the problem because it's a fraction? Would anybody here get stumped in that sense? Just because you see fractions in a word problem, you're like, I don't know, can't do it, done. And that's what we got to get over. Why are you going to sell yourself short when you don't even know what you're doing with those fractions? They're just numbers, just numbers. So we see here that we went this many miles for the clothing store. And then again, the 6 miles to the grocery store. What did we say we would do with whatever miles we had, everybody? Whatever numbers we had for miles, we see here that we went this far to the grocery store, this far to the clothing store. We said we would add them up. We got to figure out how many miles we rode up to this point. So we just add them up. That's all we can do. Now, this is where you can actually freak out if you don't know how to handle fractions. This is where you can freak out. This is where I'm cool with you going. But let's get to work here. So we know what to do. What we have to do here is we need the same denominator because we don't have the same denominator. Everybody, simple question. Can 3 go into 6? Oh, yeah. Yeah, 3 can absolutely go into 6. And so what do we need to multiply the 3 by on the top and the bottom to get to 6? What do we need to do? Multiply the top and the bottom by 2. Once we do that, we're going to have 2 times 4, which is going to be 8 over 6 plus 4 over 6. And everybody, 8 plus 4 gives us what? Correct. It's going to give us 12. And then 12 over 12, right? Because 6 plus 6 is 12, right? Nah, exactly. It's going to stay 6. It's going to stay 6. You keep the denominator the same. And then you got to ask yourself, whoa, that's division, right? What's 12 divided by 6? Yeah, 2. And so your answer is 2. So again, the main focus of that problem again was step 1. What was the question? The question reads, how many miles have you ridden so far? So basically you're just trying to figure out what are all the miles? Add it together. That's really it. And now it could be a distance rate time problem, and so we'll calculate that differently, but it just sounds like we're trying to figure out from A to B, how far have we gone? And then from there, step 2, the information that we wrote down was, yo, if we're just trying to figure out how many miles in total, if all they do is give me miles, I got to add them up. If they give me, like a rate, like miles per hour and time, well, that's distance rate time. That's a different type. Thankfully, what I saw was they just gave me miles here, miles there. I just want the total number of miles that tells me, add them up. So everybody, did that explain that a little better there in terms of the difference between, again, noticing that you just have a total problem and just add them up versus a distance rate time problem in that case? Because you would have seen rates and time, not just distances. Okay, so there is question 2. So we're going to go ahead and try to up the ante here. I'm going to give you a minute and a half again. And remember, we're not trying to solve the whole thing. I just want you to be able to get from step 1 to step 2 to then confidence with step 3, 4, and get the problem correct and know that you got it right. So 3, 2, and let me get this timer up and go. Let's try it out. So here we go. Step 1. Let's just understand what we're looking for with this story. What are we looking for? How many miles did Austin have left to run? Okay. That is step 1 right there. How many miles did Austin have left to run? Okay, cool. So step 2 is, well, first, we can't just skip step 1. Look, let me be very clear with you guys. This is something that I've seen some of y'all do as well. We don't want to just read the question and just say, yep, read the question, I get it. No, analyze it real quick. Like, ask yourself what it sounds like you're trying to do. So how many miles did Austin have left to run? Guys, that statement tells a lot. For me, when I hear that, how many miles did Austin have left to run? When you think about that, it sounds like Austin's trying to get somewhere. And we know where he's gotten up to. And we're trying to figure out how much further he has left to go. Everybody, does it kind of sound like we're going in that direction? If I say, how many miles does Austin have left to go? And I didn't read the story yet, it sounds like we're talking about Austin trying to go somewhere. And he just hasn't gotten there yet. That's kind of what it sounds like. That's kind of what it sounds like. If I had to be reasonable, I'm willing to bet that's what it sounds like. Now, let's not make any assumptions yet. Let's take the information in, but we want to know blank miles left right here. So blank miles left for Austin. Okay, now step 2, let's write this information. Let's figure it out. Let's understand what it means. Remember, it's not just about what the numbers are, it's about what they mean compared to the story. So from here, let's read. Austin started his 3-mile run but soon realized how out of shape quarantining made him. He was only able to complete this many miles of the run before he gave up. Okay, so Austin started his run. That's this long. So he needs to go from here to here. That's that many miles, 3 miles. Then he says he was only able to complete that many miles. Okay, let's write that down. Here's our information. The run, 3 miles. What have you done? That many miles. Everybody, you don't need to read the fraction. Don't intimidate yourself. You don't need to intimidate yourself. So I'm looking at that. Everybody, that was step 2. Step 3, this is where you start planning. Step 3 means, okay, we know Austin has this 3-mile run. He's gotten this far. And we're trying to figure out how much further he has left, how much he has left to go. So everybody, what can we do with what we have? We have the total that he's trying to run. We have the piece that he's done already. To get the piece that he hasn't done, what he has left, what comes to mind? Like naturally, intuitively, what comes to mind? What math idea do you think we could use to take this and that to get to this piece? Subtract. Yeah, exactly. If we have this, we can subtract all of this to get that. Exactly. So what we'll do is we'll say 3 miles minus the 13/5. That's what's going to give us the answer. Do we agree with that plan, everybody? Subtract what we've done from what we need to do to get what's left. Again, I'm just trying to talk about this in English. And that's the goal for you too. We want to talk about this in English because that's where it makes the most sense. So 3 minus 13/5. And another dead giveaway is right here. How much you have left. How much do you have left? That's another giveaway that is subtraction. Or potentially subtraction, right? Because total is potentially addition or potentially something else. But have left or how much is remaining, typically that is a giveaway of subtraction, yeah. But we confirmed it with the story so we can feel confident that we're good. So let's go ahead and get to work. We got a problem here. We got 3 minus 13/5. Everybody, do we have the same denominator? No, we don't, everybody. Remember, whole numbers, you can rewrite them as fractions. Every whole number is that same whole number divided by what? Yeah, everything is divided by 1. It's the same thing as just dividing it by 1. So what I can say is 3 is the same thing as saying 3/1. Now, we got to try to get the same denominator here. Everybody, what can 1 and 5 both go into? Can 1 go into 5? Yeah, 1 can go into 5. So what I'm going to do here is I'm going to speed up the process just a little bit to get through the calculating. But I'm going to show every step, but I want to make sure we focus more so on the word problems themselves, setting things up, even if we're dealing with fractions. So here we can multiply the top and the bottom by 5. And so what that'll give us over here, 5 times 3, that gives us 15. 5 times 1, that gives us 5. And so we'll go ahead and subtract the 13/5. All I did was, again, multiply the numerator and denominator by 5 right there. So up next, now we subtract 15 minus 13. Everybody, 15 minus 13 gives us 2/5. Everybody, 2/5 what? Remember, it's not about what the numbers are. It's about what they mean. 2/5 miles. Boom. 2 out of 5 miles, 2/5 miles left to run. Boom. So now we've completed the story. We've told the story. 2/5, B is the answer, and we're good. But remember, it wasn't about the calculation. It was about the plan. Your ability to point out the question, your ability to understand the information, your ability to make a plan with that information, and then calculating comes last. So don't worry about the calculating today. If that gives you a struggle, don't worry. We're trying to tell stories here today. It's story time. So let's get to this next one here. I'm going to give you, so Anfid, I see here, he said, why do we put the 5 only on the left side? Because over here, the goal was, remember, we want the same denominator. So right there, the 1, you can multiply that by 5 to get 5. The 5, it's already 5. So you can leave it as is right there. No work needed to be done. You can leave it right there. So Anfid, let me know if that makes sense. Cool. So here we go. Here's the next one. I'm going to give you now 2 minutes for this one here. I'm going to give you 2 minutes for this one. So let me go ahead and raise the timer. And there we go. Go ahead. Let's get started. Now I'm going to give you a little more time to try to do the first 3 steps. Can you identify the question? Can you understand the information? Can you make a plan with that information? Let's try it out. So, how full is the park if there are 180 people present? Okay, so how full is the park? And then we have additional information here, 180 people present. But the main question is, how full is the park? So everybody, what does that mean to you? What comes to mind when you're asking how full something is? How full is it? What do we mean by that? How full is something? Right, for those of you saying division, you're right. And I want to really express the point. I really want to really just illustrate this. So when you're asking how full something is, everybody, is it true that when you're asking how full, you're asking how much you have compared to how much is possible, how much you could have? So like, how full are you? Well, how much pizza did I eat? How many tacos did I eat along with that? How much food can my stomach hold? How much did I eat compared to how full I can get? All right, well, how full is the car? Okay, well, we got 2 people in the car. I drive a sedan, so we could fit 5 people. So I got 2 out of 5. That's how full it is, 2 out of 5. Okay, we can think of another example. We could say, how full is the lobby? How full is the hospital lobby? Something like that. Well, the capacity sign says 400 people max capacity. There's 200 people here. So 200 out of 400, or half. Yes or no, everybody? Do we see what I'm saying when I'm describing the phrase, how full? We're comparing what we have to what we could possibly have. And here's the thing. The main word that you might have missed, compare. Compared to. When we're comparing one number to another, that's a ratio or a fraction. So we are creating a fraction here. So over here, when you say how full is the park, how full, that's division, because you are comparing what you have divided by what you could have, or total possible, or just total. What you have, or all. Better yet, we'll just go ahead and use the word all. So what you have versus all that's possible. So let's look at the information here and let's see what we could be talking about. A local park has a maximum capacity, 600 people. Okay, max equals 600. And then over here, 180 people present. So that's what we have. So we have 180 people. Did this problem here become a lot easier for anybody? Did this problem just become a lot easier for anybody? All right, sounds good. And if it's a no, again, be honest. I'm not trying to get pandered to. I'm here to teach you. I'm here to get better. So I need you to identify when I'm not making sense, and I want you to identify when I am. And just being honest. Because again, I do want to tackle and make sure you're all good. So remember, one more time, how full just means what do we have? How much do we have compared to the total that I could have? So here we have 180 people and we have a max capacity of 600. So what that says is, yo, how full is it? You get 180 out of the 600 people. You got 180 out of. Everybody, the word out or the phrase out of means what? Divide. So what we're saying here, look, this right here means 180 out of 600 people. Everybody, is that a fair way to write that in English? Is that a fair way? Like, I'm not trying to trick you. That's fair, right? In English, we got 180 out of 600 people. So the phrase out of, we can take that right there. That's division. That's where this comes into play. And we turn this into 180 over 600. And then from there, you simplify to get the final answer, but that's what you'll do. And that's what you'll get. Yes or no? Are we making more sense, same sense, less sense? Where are we? Cool. So here, what we have to do is simplify now, and what we can do, I'm not going to explain everything fully here because again, I will make more videos and do more classes on this, but we're simplifying the fraction here. Both of those numbers end in 0. They're divisible by 10. The trick is just take away those zeros right there. So now we have 18 over 60. And you ask yourself, what can divide into both 18 and 60? What I'm going to go ahead and do is divide them both by 3. Or is there a better number, everybody? What's a better number that we could use? 6. 6 would absolutely be fair. So here I can divide them both by 6 because again, you want to make it so that you divide by the biggest number possible to give you the simplest or smallest result. So 18 divided by 6 is 3. Hey, Dwight, great job being quick on that one. But now we switch it up to the 6. So let's see if we can finish that one off now. Because you did it with the 3. Can we do it with the 6? So 16 divided by 6 gives us 10. 3 over 10. This is again called simplifying. That is simplifying. So with that, there you go. We have 3 over 10. And so we're good right there. And that is our answer. Boom. But again, remember, everybody, what we just did here with the word problem was, again, what's the question? What's the information? How do those relate? Let's solve. So let's try it again from the top. Let's give it another one here, 2.5 minutes. Let me get that timer up. And let's go. This one might be a little harder, but again, pay attention to the story here. Pay attention to the story. So over here it says, a quarter of the space in Ben's living room is covered by a rug. Everybody, what's wrong with that statement? A quarter of the space in Ben's living room is covered by a rug. What's wrong with that? What is wrong with that? What's wrong is that I didn't read the question first. That's the only thing that's wrong with what I just said. I just didn't read the question first. So here, come on, man, right here. What portion of Ben's living room floor is empty? So we're looking for the empty portion. Okay. So if we're thinking about portions here and we're asking how much is empty, that's kind of similar to saying, yo, how much is left, right? Isn't that the same thing as saying that? How much is left? Yeah, and what did we learn or kind of see when we were trying to figure out what was left in something? What did we see when we were trying to figure out how much was left? Mohammed, Left meaning what you have in total or as the whole, and subtract what you have. Exactly. Yeah, subtract. See what you have left. Take the total and subtract. Exactly. So let's go ahead and see what we have here. Empty meaning find what's left. Find what space you have left. Okay, step 2. What we're going to do here is we're going to grab our information and see what we can do with it. So step 2, bam, we're going to read through. So it says this much of the space in Ben's living room is covered by a rug, and an additional this much space is used for furniture. So notice, I'm not going to read the numbers. I don't have to. We see a quarter of the space. That is for the rug. And then we also have over here. So let me just highlight this in red. All right. And then we have over here, 5/12 of that space is used for furniture. Okay, cool. All right, that's all I expected if you did step 2. We know that that much space is for the rug, that much space is for the furniture. Cool. Okay, this is where step 3 comes into play. Step 3 is, what are we trying to do? And how does this help us? What are we trying to do? And how does this help us? So we're looking at this and we're saying a quarter of the space is for the rug. All right, 5/12 for the furniture. Everybody, what are we subtracting from? Are we supposed to subtract those two numbers? Are we supposed to subtract 5/12 minus 1/4? Or are we supposed to do that? No, we're not. Think about it like this. Think of it like this. The goal is to find out what empty space you have. Okay, a quarter of the entire living room is for the rug. All of that is for the furniture. Is subtracting rug from furniture, does that make any sense at all to find out what's empty? No. What you want to do is you want to take the whole room, subtract the rug, subtract the furniture, or the furniture, and then you see what's left. Does that make a little more sense to everybody? It would make more sense to find out what's empty. Think about this in English. Think about it in English. If we try to find out what's left, well, what do I have? How big is the room? Then take away the rug, take away the furniture, the space that you have left right here. That's what's not empty. So what I'm going to do here is think about it like this. What is this altogether? What is this altogether? I want to find out how much space that is before I take it away. So let's go ahead and add these together here. 1/4 plus 5/12 right over here. Man, I hate losing my voice. 1/4 plus 5/12. Everybody, what I'm going to do here is I'm going to show you that 4 can go into 12. So I'm going to just multiply the top and the bottom by 3. Three times 4, that's going to give me the 12 that I need on the bottom. 3 times 1, and that's going to give me 3. We add that with the 5/12. Okay, so add these together, you're going to get 8/12. Now, everybody, think of it like this. True or false? Fractions are parts of wholes. True or false? Fractions are parts of wholes. True. Absolutely true. So if you're thinking about it like this, if fractions are parts of wholes, that's a part, that's the whole. Well, guess what, everybody? How much more do you have to go from 8 to get to 12? Like how much more? Because you have 9, 10, 11, and 12. So how much is that? How much more do you have left to go? Yeah, 4. So again, this is space taken up. And then if I over here, if I write 4 over 12, and use a different color actually, make it more consistent. This is this empty space. Again, the idea here is the 12 is the whole, the 12 is the entire thing. So if you're saying, yo, if I go ahead and draw like grid blocks to represent my room, and I can cover the room with 12 grids, with 12 blocks, 8 of those squares, of the 12 squares that you see for the grid, 8 of those squares are taken up. That means 4 of those squares are not taken up or empty. And so you have 4 over 12 is your final answer, but you may have to simplify because 4 over 12, both divisible by what? 4 over 12 is they're both divisible by what? They're both divisible by 4. So I'm going to go back in a second right here to explain again how we get that 4. I got you. If we divide both the numerator and denominator by 4, we end up getting 1/3 as the answer. So the answer is going to be 1 over 3. So let me explain again where we got the 4 from. I got y'all. So right over here with the 4, think of it like this, everybody. The 8 out of 12, remember, a fraction is a part over a whole. Part over whole, part over whole, right? The denominator, that represents the whole thing. The part, it tells you how much you have out of what you could have. So when you think of it, to go from 8 to 12, well, if you do the math here, 12 minus 8, that's going to give you 4. 12 minus 8 gives you 4. So you are 4 away to get to 12. Everybody, does that make sense now? Again, 8 out of 12 means you have 8 out of 12 pieces. How many more pieces do you need? 4 more pieces. And that's where the 4 comes from. That's the empty space because 8 and 4 together makes 12. These two together make 12. And I can show you right here too, just to make sure. Think of it like this as well. 8 over 12 plus 4 over 12. Everybody, if you add 8 out of 12 and 4 out of 12, we get 12 over 12, right? Okay. So if we have 12 over 12, 12 divided by 12 is 1. Exactly. It's going to be equal to 1. And so with that being equal to 1, that's all we got. That is 1, the whole thing. 1 means the whole thing, the whole living room per se. So I want to make sure that we kind of carefully explain that there. So hopefully I did drive a point across. Let me go and give you the opportunity to kind of take a screenshot if you'd like to. Hey, no worries, Lewis. That was the calculating part. As long as you got that we were trying to find out the empty space by taking away what we had, you're good there. We'll go ahead and I'm going to guide you through. Hit me over to the class. I'm going to guide you through the multiplying, dividing, adding, subtracting portion of it. I got you. Same thing with you, Giselle. So there's the whole problem. Feel free to take your screenshot right there too. Got you. Then hit me up about that and I'll make sure I take care of you there. Thank you. Thanks for being specific there. So there's the whole problem. All right. Hopefully you have enough of a chance to take a screenshot there. So please, folks, go ahead and articulate your questions. So iPhone, let me know what your name is. Again, iPhone, not sure who you are, but go ahead and let me know what your name is and what the question is, because we're going to keep focusing on that in this next one. So for those of you guys with your hands raised, type your questions into the chat box and I'm going to reply to them as we're working on this next problem. I got you. Got you, Sarja. So go ahead with this next one here. Let me go ahead and start the timer there. And so just to make life easy for us here, I'm just going to go ahead and write this 2.5. That is 2.5. Or you can also write this as 5 over 2. So I gave it to you as a mixed number, improper fraction, and a decimal, whichever one you want to use. Go ahead. So we're talking about some object here. If he stretches it to 3 times its length, how long would it be? Okay, so we're looking for the length. We're looking for the length. That's 3 times. We're looking for the length times 3. That's what we're looking for. Sounds good. We're looking for whatever this length that we're talking about, because it says stretch it to a length 3 times. And so from there, we're asking, how long would that be? So let's measure it. Find the distance from here to there, but it's 3 times something else. Let's go to the information to see what they're talking about, because they didn't say what the object was. Yeah, it says rubber band, but it could have been like, a stuffed animal, could have been whatever, a cartoon stuffed animal, because those actually stretch. It could have been whatever. So you got to understand what we're talking about, just to get a little context in there. So here, that was step 1. Step 2, we have a rubber band. Right here, Jordan has a rubber band that is 2.5 inches long. If he stretches it to 3 times the length, how long would it be? So let's think about the story there. We have that rubber band, and that rubber band is 2.5 inches long. And we're trying to figure out what that length is times 3. Everybody, did they kind of give away what we need to do here? Did they give away what we need to do here? Kind of gave it away, right? 3 times, yeah, kind of gave it away. And so what we're going to do here is we'll go ahead and calculate nice and firm. We're going to be multiplying the length by 3. The length is 2.5 inches. We'll multiply that by 3. And let's get to work. So when we do this, everybody, and I know someone here had the question earlier, how do you convert from improper to mixed or mixed to improper? This is our opportunity right here. We got this. So let's go over this here. 2.5 times 3. The question is this: do you have to convert the mixed number to an improper fraction before you multiply? Do you have to convert it before you multiply? I see a lot of yeses there. I see a lot of yeses. Okay. Okay. I'm going to go ahead and pretend to agree with you for right now. I'm going to do the problem, and I'm going to show you what I meant when I said pretend. So here we go. 2.5 times 3. Let's go ahead and remind ourselves, how do we do a mixed to improper again? Remember this. Everybody, fractions are parts out of wholes. The whole number here, the 2, means that you have 2 of these in the fraction. So what you do is you say, hey, I'm going to multiply you right here. I'm going to multiply, and then you're going to continue on up here and add. So everybody, 2 times 2 is 4, plus 1 gives me a new numerator of 5. So this changes to 5 out of 2. Again, step 1, multiply. Step 2, add. So from here, we multiply this by 3, but everybody, isn't 3 the same thing as saying 3 over 1? Yep, we're good. So what we'll do now is we'll just go ahead and multiply these fractions together. There's nothing we can simplify, nor am I going to take the time to do that right now. So 5 times 3, that's going to give me 15. 2 times 1 gives me 2. So from here, okay, 15 over 2. Oh, none of my answers are an improper fraction. So I'm going to have to turn this back into a mixed number. So let's ask ourselves here, how many times does 2 go into 15? How many times can 15 be divided by 2? That's the biggest question there. Yeah, that's going to be 7. So this turns into 7. So we have 2 goes into 15. 7 times with a remainder of 1. So that means it's going to turn into 7 with a remainder of 1. You have 1 left out of 2. And so that would be 7.5. That would be 7.5 right there. But I want to show you the other way. Remember earlier how I said, I'm going to pretend to agree with you. Allow me to teach you some mathematics. So let me just quickly hear some cool stuff. 2.5 multiplied by 3. Right here. All right, let me show y'all something real quick. So I'm going to split and glue this. So watch this. Split and glue time. Everybody, what's 3 times 2? Great. And then over here, what we could do is the 3 times the half. And that's going to give you 3 over 2, 3 halves. Because you know the 3 goes up top. So 3 times 1 gives you 3. And then you leave that 2. So you're looking at that and you're saying, oh, whoa, that's a mixed improper fraction. Hey, say less. I got you. Because what we're going to do is just say, hey, yo, 2 goes into 3 one time. So we can take a 2 out and make it a 7.5. So let me actually turn that into this. So you can absolutely do that with split and glue if you wanted to. If you don't know the split and glue technique, don't worry, don't worry, don't worry. The split and glue technique is mental math, and this is how you can apply it to fractions. So just wanted to go ahead and show you that there. Okay, I got you. So what I did was I just split it up into the 2.5. 3 times 2 is 6. 3 times half is 3 halves. So from there, I noticed that I could change this part into a mixed number. So let me go ahead and show you here. Move that down here for a moment, because this equals the 6 and 1.5. So that's how it becomes 7.5. Because the 3 over 2 is the same thing as saying 1.5. And so you can take the 1 and the 6, bring them together to make that 7 right here. So you could do split and glue, just giving you a nice little sneak peek at it per se. But yeah, so you don't have to do it this way for sure. You definitely don't have to do it this way. If you've been practicing fractions for a minute now, this will make more sense than not. If you're still, getting the ropes of refreshing, don't worry. You're absolutely good. No worries, Raquel. So with that, I'm going to give you guys one more question here, and then we are going to call it a day. So here we go. 3, 2, 1, go.
Hey, if you'd like to watch all the classes, get all my practice problems, and text me whenever you need help with anything at all, then check out my ASVAB All-Access Program. It's everything you need to succeed. It's how my students raise their scores and get the jobs they want all day, every day. Oh yeah, and by the way, I got a master's degree in teaching, and I've been teaching for over 10 years. I put you first. I'm passionate about it. So check this out, and let's get to work. Let's ace the ASVAB.
If they work consistently or constantly, how long will it take to remove the dirt? So how long will it take? Everybody, what does how long mean? Quick. How long means we're looking for what? How long will it take? Not how long something is, but how long something will take to get done. Time. So what we want here is time. So time to remove the dirt. Okay, great. Okay, so we're looking at what we have to remove. Let's look at our info here. So the goal is 10 tons. Okay. Then it says they can remove 2/5 of a ton of dirt every hour. Tons of dirt every hour. Tons of dirt per hour. What is that, everybody? 2/5 of a ton of dirt every hour. 2/5 of a ton of dirt per hour. That is a rate, everybody. That is a rate. So right here, the rate, that's a speed. 2/5 tons per hour. The word every is the same thing as saying per. Like of dirt every hour, that's the same thing as saying per hour. Same thing. That's something we do want to understand. So memorize that fact there. So if you're talking about how much of this for every piece of time, like miles per hour, dogs per year, laps per minute. When you use the word per to connect two things, that is a rate. So boom, I'm looking at a distance rate time problem, everybody. I'm going to solve this right now. This is a distance rate time. Our goal is 10 tons. D equals R times T. So the goal is 10 tons. The rate is 2/5. And time is what we're looking for. So if we solve this, we're good. And once you solve this, to do this, you have to divide both sides by 2/5. Is to divide by 2/5. And this turns into a dividing fractions problem, because you're going to have essentially 10 divided by 2/5, which turns into 10 times 5/2, which turns into, I'm saving you the time because I ran out of time here, 25 hours. And the answer there would be D, 25 hours.